Welcome everybody to this week's WPI System Dynamics Collective Learning Meeting, which is also the System Dynamics Society Economic Special Interest Group monthly meeting. Please remember to mute your microphones unless you want to ask a question. Feel free to use the chat box. If you type a question there, I, Christine Tang, can ask the question for you. You may ask questions at any time. Our presenter today is Al Thibeault. Al is a professional engineer, president of Emistra Consulting Ltd, and an energy engineering PhD student at the University of North Dakota. Take it away, Al.
Thank you very much, Christine. Welcome, everybody. So I did it. The slides will be available for download. I did put a little bio in there, but I'm not going to spend any time on it. So my objective today is to just describe the research problem, my thesis that I'm working on. It has to do with rare earth elements, and we'll give a bit of background first, and then talk about the problem and the hypothesis. But the real goal for me today is to seek wisdom. So there's not going to be a lot of system dynamics content today. I have started working on causal loop diagrams and some smaller models, system dynamic models, but today I'd just like to get some feedback on formulating the problem and making sure that research is going in the right direction. So the issue with rare earth elements really started in the mid 80s, and actually what does that mean? I'll just go back up. Rare earth elements are technically 15 elements in the lanthanide series of the periodic table, and they're not rare. They are earths according to the chemistry at the time in the late 1800s when they were first discovered. And then there's two other elements, scandium and yttrium, that are not technically in the lanthanide series, but are close enough in their chemical properties that they're quite often lumped in. So if you're seeing a popular media discussion about rare earth elements, they're likely talking about all 17 of these guys. And we'll get to it a little in a couple of slides, but they have some really important properties for some critical industries. So I'll just with that little bit of introduction and just understanding that the rare earth elements, some of them for sure are really important. The situation with the rare earth elements today is that there really is one very dominant producer, and that's China. That it didn't always wasn't always that way up until the mid 80s. As you can tell here from this diagram, that there wasn't a ton of rare earth production up until the mid 80s, but China, to their credit, understood the strategic importance of these elements, and when a really critical event happened, that the U.S. and the International Nuclear Agency reclassified rare earths as a source of radioactive material. Where rare earths occur naturally in the ground, the mineralization, they're almost always associated with thorium, sometimes radium. And then, of course, if you're looking for the rare earths, then those two guys, thorium and radium, are the waste materials. And radioactive waste that gets people's attention. So when rare earth elements were classified as radioactive source materials, the mining in the U.S., continental U.S., basically stopped. China understood the strategic importance, and so their production of rare earths skyrocketed, as you can see, to the point today where they supply, depending on which figures you look at, between 90 and 95% of the world's rare earth elements. And So that's in and of itself, having one dominant player isn't a problem until it's a problem, and that problem occurred in 2010. There was a seemingly innocuous event on the Sea of Japan. Uh, some Japanese fishing boats were caught fishing in what China thought was their territorial waters, and so the elements of the Chinese government, not the formal central government themselves, but a regional part of the government, embargoed rare earth element shipments. That the embargo only lasted for a couple of months, but as you can see, for the impact on rare earth prices persisted for a little while longer. So if this looks like the results of a bunch of students doing the beer game, that's exactly what happened. So when the embargo hit, uh, companies uh, tried to buy up stocks. So now all of a sudden stocks are in short supply because there's the accessible stocks are in short supply because the main stocks in China are embargoed. So short supply, prices increase, and then when the flow of materials started again, the prices came down. Uh, so a couple of interesting things happened as a result of that. One of them is this chart here. MCP was a stock ticker name for the major U.S. rare earth producer at the time, Molycorp. And uh, when the prices rose, of course, so did their stock price. Then there were some interesting business decisions, and when the prices fell, the result of some of those decisions led to Molycorp going bankrupt in 2015. And of course, the environmental concerns about radioactive waste were really amplifying, and so those combination of factors led to the dominant U.S. producer going out of business. So where the reason I'm presenting this slide is because the the problem I'm going to describe for you is that even though the supply chain recovered, the value chain is starting to exhibit some problems. The value chain being the companies that need to make a profit and stay in business in order to participate in the supply chain. So we'll continue on that theme. But before we do that, just a slide on uh, why are rare earths important? What are their uses? They're in everything from magnets, glasses, catalysts. You can see the list here. And these aren't just uh, any ordinary magnets. These are the best magnets in the world. The formulation of neodymium, or one of the most important rare earth elements, in combination with iron and boride, makes permanent magnets that are unmatched for strength and high temperature characteristics. So they're used in everything from wind turbines, electric vehicles, and mobile phones, and so much more. So as you can see, as those sectors of the economy that I just mentioned are on fire right now. So we're looking at a better than 50% increase of forecast demand for the rare earth elements involved in magnets, which uh, this is a bit of an eye chart. I apologize for that. I was trying to get everything on the same slide, but praseodymium, neodymium, samarium, terbium, dysprosium, these guys uh, uh, are used in different kinds of rare earth magnets. And also, if you look at their prices, are the most expensive. Uh, so right after the big supply chain shock in 2010, that got a lot of people's attention. Um, Mr. Nasser, Dr. Nasser, was engaged by the U.S. Geological Survey, put together a great report and a great chart here. Uh, this axis is essentially the strategic dimension and then the critical dimension. So plotting critical metals, critical minerals versus strategic metals, you can see that few of the rare earth elements are quite predominant in this chart. Just recent. Oh, this is an interesting part too. The Biden administration, one of the first things they did when they came in 2021 is they commissioned a 100-day review of key supply chains, and critical minerals is one of them, and rare earths are included in critical minerals. And one of the interesting points in there is that even though the rare earth industry only contributes about $3 trillion annually to the US GDP, those elements are involved in industries that can contribute $20 trillion to GDP, and they're in strategic industries. So really great piece of work, this. So what's the state of the industry? Continues to be dominated by China, but post 2010, Australia, US, EU, Canada, Japan implementing policies to reestablish their stable supply chains and processing chains. I'll talk about this in a second, but one of the key things that happened during this period from 1980-85 until now is when China took over the lead role in supplying rare earth elements and everybody else stopped. Not only did they lose that supply chain and domestic supply chain and production capacity, they lost the knowledge. So here we are today, trying to reestablish domestic and friendly sources. And the first place they have to start was rebuilding the knowledge chain too. Interesting point about recycling. The previous chart showed the forecast for the explosive growth in rare earth forecasts. That's going to be mitigated somewhat by research into substitution materials, but let's just say it's going to be a big surge in demand. One of the sources of rare earth is recycling. Circular economy is a big topic in rare earth discussions, but China prohibits the importation of used items. So if you recover the rare earth components from old hard drives, for example, University of Birmingham has a really interesting way of doing that. That any finished good that's made with recycled rare earths can't be imported to China, and China's economy growing so much, a target for a lot of global trading. Any item that uses used rare earths isn't allowed in the country. So just to carry on, I'm heading towards the part where I explain why the supply chain and the value chain are both required in order to make a stable rare earth industry. We'll start with the supply chain, and this is essentially what it looks like. It starts with exploration, finding the source of the minerals, through to mining, processing, et cetera, et cetera. The actual rare earth content goes through these stages. First is called a concentrate, where they take out as much of the unimportant minerals as possible just through crushing and mechanical separation. Then they go through separation, chemical concentration, and the next step is called rare earth oxide. So most of the mineralization is removed by this stage, and then in the final refining, the 99.99% pure metals are derived. That could be sometimes that's sufficient processing for some products, some manufacturers. For others, like the magnets, then the neodymium and other significant rare earth elements go to the final processing stage to make the magnets where they're alloyed with other minerals. So one thing that I found just recently was when I was uh, pulling together this slide, and I noticed that it bears a whole bunch of similarity to this supply chain here. Mines, concentrators, smelters, refiners, fabricators, manufacturing. So here's the interactive portion of the presentation for 100 rare earth bucks, which aren't worth anything. Does anybody know the source of this supply chain diagram up here? It goes back a ways to Dr. Forster. It's in industrial dynamics. Uh, so my involvement with system dynamics is actually relatively recent. Uh, Industrial dynamics was recommended many times as a must read. So I started, and I would echo that sentiment. Dr. Forster was supervising a PhD student, Ray Ballmer, and Ray pulled a lot of this together and worked with Dr. Forster. So this is actually the copper supply chain that was mentioned. I'll just check. Okay, very good. Oops. Next. So I keep mentioning value chains, introduced by Dr. Michael Porter in mid 80s, coincidentally. So what's the difference between supply chains and value chains? Supply chains are really about material movement and efficiency, reducing costs, increasing margins, whereas value chains are really all about profitability, getting paid for your value add. Uh, so I tend to think of it as supply chains are the materials flowing left to right. Value chains are the information, including payment. If you want to think of money as digital, flowing from right to left. The customer will pay you for the value add, and then the payments all the way back down this supply chain um, keep the whole thing going. There's other differences as well. Good paper by Dr. Fern. And then I pulled it together in a different sort of a look. So the different stages of any product in general. Um, but I applied it to rare earths. The investment profile is uh, just relative to the cost of a greenfield mine. These are hundreds of millions of dollars, and because of environmental regulations, can take 15 to 40 years in the extreme. It tends to be around 15 to 20 years, but hugely expensive. So this is 4 bars. Everything else in the investment profile is relative to that. Buyer-driven value chains are chains that tend to be dominated by consumer products, whereas producer-driven value chains are more commodities. These are somewhat classical definitions, and they've evolved a bit. But buyer-driven, just in simple terms, customer feedback is critical. That they want to be able to shape what the end products look like that are being delivered to them. They don't want to just take the standard widget off the shelf. Whereas in a producer-driven value chain, standard products are going to tend to be quite acceptable. The supply chain really deals with these 4 items here. So why is value chain important? Because it supplies critical feedback to the supply chain. This is I did take, oops, really interesting course from Dr. David Simchi-Levy at I was attending MIT Sloan Executive Education, and made a great point, that there's only so much you can do in a business with supply chain. You can refine your, manage your costs, get more efficient, but growing the business is going to be difficult if the only lever that you're pulling is your supply chain lever. You need to pay attention to the value chain, improve your products. And here's a great example. This is from a story in the Washington Post. The money floodgates were opened early in COVID to the tune of billions of dollars to produce ventilators in an awful hurry. But the problem was, by the time those ventilators were being produced, and it was a rapid ramp up in production cycle, but even in that short period of time, because of the intensity and the pressures on the medical system, they learned how to deal with critical COVID care by reducing the need for ventilators. So by the time these ventilators, 95,000 of them were getting delivered, that huge need had gone away. If there had been some value chain, feedback going back to these really great companies, Ford, General Motors, really pulled their weight to get ventilators going, but turns out that now we have a lot of them that are still in stockpiles. No feedback. We know all about that. So here's a different view of the supply chain, and with the value chain added. And this is my first attempt to show feedback going back down from right to left. Just a brief plug for the University of North Dakota. We've been doing research into extraction of rare earth elements from coal, lignite coal, for quite some time. Dr. Dan Laudall's director of our Institute for Energy Systems now, and so his research put together this part of it in the box for his dissertation, and then I've added these value chain components at the back and the front and the back end. So the earlier slide about the forecast for huge need for rare earth elements would tend to lead you to the conclusion that a product producer-driven value chain is all that is the most appropriate value chain for this industry, because if we need that much, just open the floodgates and just produce everything. But here's as you drill down into it, here's a situation we're looking at all the different formulations. These are formulations for permanent magnets, neodymium permanent magnets, and you can see that each one of these is slightly different, different magnetic properties and different temperature characteristics. I know this is going to be tough to read, but you can see in the different industries from that previous chart which ones that they're using. So now it isn't just about producer-driven value chains anymore. The customers want different magnets and different formulations, and if they can't get them from these materials, then the substitution effect is going to kick in. I have to figure out how to model that. So here's the hypothesis that to have a stable industry, we need both supply chain and value chain to be operating well. my plan is to put together a model to do exactly that, to show the intersection of value chain and the supply chain. Working definition of stability for long-term stability. Supply chain has frictionless movements of goods from mine to manufacturing. The value chain is frictionless payments for real value add, excluding economic rent. So the concept of uh, 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 cost that's in excess of quote unquote reasonable profit just doesn't add value. And so yeah, and real is value added to the product. But it also, stability means no government transfers in the long term. Obviously, the dire situation of domestic rare earth element industry now, especially the lack of knowledge, really skilled people, means that subsidies are appropriate and essential in the short term. But in the long term, we all know, well, most of us know that government priorities change, policies change, funding targets change. At some point, uh, it's just a huge risk to the industry to continue to rely on subsidies. And also, if you're relying on subsidies, maybe you're just not being as efficient in your industry as you can be. So I'm going to include um, some means of looking at optimizing for uh, government transfer payments. The other thing for me that's exciting is this is happening in real time. So this was from October 7th. DOE's just funded uh, uh, a domestic processor in Wyoming, uh, producing permanent magnets. So it's just uh, it's really motivating. Be looking at a real time problem. This is where I give a big shout out to Dr. Wheat and his macrodynamics class. There's a really great description of his macrodynamics model in their recent book. Dr. Radzicki, also an editor of the book. There he is. Fascinating book. This is my version of adaptation of macrodynamics. We were told to do that, right, John? So here's, I mentioned government subsidies, so I'll amplify that part of the macroeconomic model. Policy regulation and stimulation flow of funds, supply leading to inventory, so GDP and aggregate demand. I kept the supply chain intact over here, even though you could say that alloying that final manufacturing, I'm not sure if this is correct actually, if this should be in supply, but I've left it in demand for now. And then uh, the impact of foreign um, uh, agents in the study. Should also mention that in China there's a huge problem with regulated supply, legal supply, and unregulated supply. Uh, I'll just leave it there. That's a 30-minute talk for a different day. But there are the unregulated supply is market distorting. That's one factor, but there's absolutely no respect for environmental standards in this supply group. So that's an even larger concern. Done some thinking about scenario testing. I've been an engineer long enough that you know that developing your quality plan at the beginning of the project is a way better idea than shoehorning it in at the end. So I've started thinking about scenario testing, and that's where I'm at.
So what would you say is the driving question?
I would, I would, I'm still trying to confirm the impact of the value chains. Um, like right now, it's a hypothesis. There's all this billions of dollars being poured into the supply chain, and essentially zero talk about value chain. Like there's some really clever people working on this problem, and just leveraging the value chain into the equation is. I just have to. I, there is research. I just didn't invent this. There's some really good research. So it's just how does the value chain impact the supply chain is the driving question. I see Lydia has a question.
Hi,
Hello.
thanks for this. And where does the planet fit into your supply chain?
Where does
The planet.
the climate?
No, the planet, the Earth, the planet.
Yeah, that's that will be that gets that is going to get built in here in the policy regulation side. So for example, if there was a carbon tax, now that doesn't, it sort of applies, it doesn't really, but the regulations about radioactive waste and those things would start here in policy regulation. They would eventually show up in a macro model as a cost, and get factored into the supply sector.
Because you are talking about a stock that is being depleted, right?
Yep.
Yep.
Totally. John?
Al, I got to say, I'm impressed. This it's way out of my domain, but the orderly way in which you've set this up, I think, says to me, among other things, oh yeah, he's a longtime engineer. Of course, he set it up this way. I have one technical question and then one observation, and let me take them in reverse order. I think it's really interesting that you've set up the value chain as that you described it as the information flow, in particular, the money piece of this, which totally makes sense to me, but only in one direction. Because when we think about, because prices are a signal,
right,
in one direction. The lessons learned are not as volatile. That the lessons learned from that information flow are perhaps a stock or a series of stocks, whereas the perhaps the prices are a variation. So and I'm wondering whether or not, again, I think that's a very creative definition, at least in my world. But I'm wondering whether or not it would be useful in order to avoid a whipsaw effect, a beer game effect, to separate the learning the information flows into two directions. I need to think about that more, and obviously I know how to find you because of class.
Yes.
My small technical question is with respect to the policy of the Chinese government on recycled elements. Is it, from a technical perspective, is it, how is whether or not the material is recycled known?
That's a great question. I don't know all of the answer to that. About 6 months ago, Rare Earth Industry Association had a great webinar about this very topic, and there's a lot of attention being placed on traceability of materials, but in terms of an absolute answer, I'm going to go out on a limb here, and I suspect it's due to their knowledge of the industry. They are involved in the whole industry. If somebody else has a better understanding, I'd be happy to have them chime in. But I don't think there's any technical way of. There's no tracers in it right now. I think it's more industrial knowledge.
Thanks.
But that's a good point, though.
I mean, given that the material is, as I understand it, you said that is it actually radioactive? Is it okay? So it couldn't be traced like the fallout from a nuclear power plant or bomb or something like that.
No, actually, thank you for that. I will make it more clear that once the material is processed, all the radioactive components, all of it, 100% is extracted.
Thanks, Al. This is really a fascinating problem.
Oh, thank you, Daniel.
Yeah, hi there. Thanks for that. I'm very interested, and I'm actually a mining engineer originally before I got into system dynamics. Now I consider myself a part-time economist. But just to start with a simple sounding question, why are you interested in this topic?
A couple of reasons. I live in Saskatchewan, in a province in Canada in the Midwest, and our geography contains the largest deposits of uranium in the world. All the dominant players, Areva and stuff, are in our northern part of our province mining uranium. It was more active at one time when people were still building nuclear power plants. Maybe SMRs will get that going again. One of the only rare earth processing facilities outside of China is the pilot project's being built about 2 hours north of me by the Saskatchewan Research Council. They've got an engineering partner from Australia, part of the Linus organization, helping to do that. So it hits home, and then when started talking with Dr. Mann about a good research topic, and North Dakota is trying to do doing rare earth element research. They're building a processing plant there as well. It's just all those things hit home, and interest really peaked.
Okay, thanks. And somewhere along the line, I don't know whether recently or further back, you came across system dynamics and some kind of light bulb moment of some kind, maybe?
Another good question, and I'd been a consultant for many years, and in 2009 I decided it was time to hang out my own shingle for various reasons. So my company is 3 people, me, myself, and I, and so I decided to treat me to some training, and I went to MIT Sloan for their executive education series. And my very first class was on business dynamics. Unfortunately, Dr. Sturman wasn't. He's typically one of the teachers of that class, but we had some great folks, Dr. Bradley Morrison, Dr. Mark Page, Dr. Jim Linus was there. I got my free copy of the Business Dynamics book, and it took a while for the opportunity to take off, but then it did.
Okay, well, yeah, what I was getting to was that I was just trying to work out why you're studying this, and one interesting feature of that big price spike made me think, well, did this all become a big issue back in 2010, and now the price has subsided? It's not really a big issue anymore until there's another spike, and so therefore it's all kind of receded in the background as one thing. And then as a kind of a follow-up, a more general follow-up is that do you actually have industrial involvement in your project who are kind of pushing you to work this out, so that you would have to at least address the question, what is this systemic modeling or system dynamics modeling? What value is it adding to this analysis other than you would do as an engineer or as someone studying supply chains? What's the added value of system dynamics? So really kind of several questions there, sorry to confuse you. It was about the price spikes. Does that mean to say that it's not an issue anymore? Do you have industry involvement with the project, or is it just you kind of pushing it as an idea, something I'm interested in? And the third thing was, if you can remember that, what is the added value of system dynamics? Sorry if that's too much.
A very complex question. I'll try and sort through it, but let me know if I miss anything. So it started with intense personal interest, but then I reached out to the Canadian federal government, one of the department that takes a lead role in mining is called Natural Resources Canada, and I've reached out to the folks there. Janice Zink is the director, and she's really involved in this, and it matters to Canada. So I'll just leave that part there. And so they've been very helpful. I'm able to, part of their workshop seminar. So next up, very soon on my research is to reach out to the folks that I've met through NRCan with surveys and get that industry engagement for Canada. There's quite a lot of activity in Canada about rare earth elements. And why it's important is even though there was a previous spike that subsided, starting with the trade negotiations in the Trump administration with China, rare earths were on the table. Everybody understands who's the big dog in this dog park, and there's enough on the table. I'm not a policy expert, but it's been mentioned frequently enough that there's a significant concern, and hence the White House review of supply chain and dumping billions of dollars into the industry.
Great. And just a final thing was, what do you think the system dynamics adds in value to this?
So I think the value is that the value chain component is going to mitigate the spikes in the supply chain. Those could always happen for intended and unintended reasons. So the supply chain issues that we're seeing in the world today aren't a result of any political action. They're just COVID and other market forces. So there's always that possibility, but the value chain is also going to provide the feedback and the payments, I'm going to think seriously about John's observation. So just using the value chain information to smooth out the bumps, so to speak, eliminate the whipsaw.
Thank you.
Thank you for the question. That's great.
So in the chat, Ivan Taylor wrote that he agrees with John and prices are essential to consider here. They represent a strong signal and would make the feedback system easy to understand, don't you think? I wasn't so sure if that was a rhetorical question.
I'm just looking at, oh, Ivan's here. Hi, Ivan. Sorry, could you say that again? I'm trying to look at it in the chat and I'm not seeing it. I'll pay attention to your voice and not my screen.
So he said prices are essential. They represent a strong signal and would make the feedback system easy to understand, don't you think? And then there was another part of this is, don't you think that your example of the ventilator glut might have been caused by a disconnect in the price signaling? So it's mainly about feedback and price signaling.
Yeah, I don't know for sure, but I don't think the ventilator example that the price signal would have helped there. They were opening the fire hose, and the price was just not an issue at the time. The hospitals weren't being asked to pay for these ventilators; they were just being supplied. What the signal that I was thinking of is that as medical expertise increased and the need for ventilators decreased quickly, that signal did not get back to the emergency supply chain, and they could have dialed it down, saved some money by dialing it down sooner. So, but that doesn't negate the first point. I take that's a great observation. That's prices are essential to consider, and I'm going to go back and take a look at that. Glad to see Ivan on the call. We emailed back and forth earlier. I wasn't expecting him. Glad he's here. Sam, I will get a hold of you.
Oh, Ivan has something else. I think that many early SD models like industrial dynamics and world dynamics were missing the price components.
A lot of them were. Dennis Meadows, Dr. Meadows, published a really great piece of work, dynamics of commodity chains, and his work did include prices. Pricing signals has evolved a lot since that 1973 work. It was a really great and important piece at the time, opened a lot of eyes, but I'm using that as a motivation, a source of ideas for price. So I wouldn't want anybody to think I wasn't aware of price, but I just hadn't included it in an obvious way in the model, and I do need to really bring that forward as in the work. So.
Are there any other questions or comments?
Yeah, hi, I'm sorry I came in late to the meeting, but I'm interested in hearing your thoughts about what are some of the other stakeholders that might be involved in the feedback system here? Like, is the auto industry, like, do they have a separate type of, are there separate stakeholders that have different, I see them here, are demand, alloying. Is that different stakeholders that have interest in this industry?
Let's see if we can do this. Here's here are some of them. One very notable omission from this slide is the defense industry. Permanent magnets are used in a variety of military products, drones, etc. But these are some of the bigger sectors that are involved. So they're involved in a couple of ways, from the buyer-driven value chain, obviously, but also I mentioned the rare earth permanent magnets tend to be on the very pricey side, and there's as much research on substitution materials right now as there is on improving the quality of the permanent magnets and other formulations for specific industries. So to me, that just another reason why we have to pay attention to the value chain. Otherwise, we're going to produce a whole bunch of stuff that nobody needs.
Yeah, and I guess my question about those stakeholders is that do they have accurate information about the supply of rare earths, and is it important, do you think, to the dynamics of that you're looking at? And another group might be perhaps like indigenous people often live on the land where these kinds of things are being extracted, and do their perceptions about things, does that influence the sort of different pressures that are going into this supply chain, and are they important, I guess, is my question. Or have you seen it in the literature that you've been reading and other activities you've been doing?
I don't know the answer to that question, but what I can tell you is that this afternoon I'm taking my introductory to Qualtrics course. So my plan is to engage with first with because I have access to them, to the industry folks that are part of the Natural Resources Canada working group on rare earths, and then maybe extend it out, the surveys out. But I understand the importance of that point, and I don't have a good answer right now.
Thank you.
We also had a couple more comments in the chat. Kareem said regarding why prices were not included in world dynamics and industrial dynamics. Were they missing, or they actually were intentionally left out? And Forrester explains why he intentionally left them out in the seminar series. And please watch the seminar series if you're able to. That also has to do with the time horizon of the model. And that also has to do with problem statement. Okay, then Kalechi said, nice presentation, Al. What are your next steps for modeling this? I did hear you talk earlier about a CLD, and also, you will be working with stakeholders. What you said.
I'm just exactly. So my plan is to survive this semester and finish off my classes, and then I have research classes planned for in January, and then keep working on the causal loop diagram for sure, but also to start with some small models. So, for example, one of the, I know we're probably running over time, but
no, we still have 2 minutes.
Okay, if I go back to here, one of the seriously interesting things, I started the stock flow model, but just couldn't get it done in time for this presentation. During the processing of the rare earth minerals, the composition of any particular mineral at any particular mine depends on the source rock. but the rare earths just it goes back to the chemistry and why they're grouped the way they are. The 17 elements tend to be grouped together is because they live together. They love each other just from the atomic models. So when that happens, when you crush, when you mill, when you process, all of the rare earth elements and that are in that mineral come out in the concentrate, and then up until the final stages of separation, they all live together as well. And it's not until this final stage of separation that you start to see individual rare earth oxides. So as the demand for rare earths skyrockets, you're going to be crushing not just the one element that you need. You're going to have to crush. You have to take all of them and then go through the cost of separating them out to get the one that you need. So the waste material isn't just the parts that aren't rare earths. It's all the rare earths that you don't need as well. Some of them are incredibly cheap, like cerium used for polishing glass. There's a glut of cerium. So the net effect is it drives up the cost of the elements that you do need. And as the demand for those elements increases and the cost of production increases, I think that would be a very interesting model.
Which is that? That's a thumbs up. Thank you.
Okay. Thanks, Koichi.
Okay, we're 1 minute past the hour. Stop the recording.